Good morning to everybody. This is Sivarajan, Assistant Professor of Computer Science at GT Arts College in Dandakal. Now we are going to discuss about DBMS. And DBMS is you know that much more concept already discussed. Now we are moving to the another segmentation is called RDBMS, that is called Relational Database Management System. Previously we discussed what is difference between the DBMS and what is difference between RDBMS, and we have to lot of examples related to the RDBMS. Now we have to go for an slightly move on the one step assessment for the relational algebra and relational calculus. Okay, now in the session what we have to discuss, I just give the some slide assessment for the relational algebra and relational calculus, and we have to move and the list of what are the relational operators are there, and what is the mean by and join operations, and what is the join operation, how to utilization and a relational table within the consequential manner of unions and join with the operators. Okay, we just elaborate something more and more concept we have to introduce than this concept as the first of all, what do you mean by a relational concept? We see the move on the next slide. Okay, move on the next slide, we go for an next one. So first we see the definition. Okay, what is mean by a relational algebra? It is produced a query language. It consists of a set of operations that takes one or two relational as the input procedure with finding the new resolution. Okay, that's the meaning. The DBMS previously we discussed something likewise, you have to construct or you have to normalize something elaborate with your DBMS. We have to consider some methods are follow, but relational algebra it's totally different, because that relational algebra it's move on the some innovatively thoughts that's purely based on the some mathematical applications. Okay, so that is called the query languages apply some mathematical terms, that is called the we have to constraint. It is called table, that is okay. So why another one I am telling the main reason is why we go for the relational tables or relational algebra, which means we finding the some new ideal solution, that's mean compared with the two different table. For example, I give it as table 1 and table 2, we merge something likewise, or you have to follow some constraint, we have to ideally resolution for and this relational algebra. We move on the slide difference and slightly more and more advantages and precise of your DBMS, and what are the briefly I have to elaborate in next slide. Then list out what is the base fundamental concept is accuracy of your relational algebra means the selection process is there. Okay, then also projection, then Cartesian product and union, and also set difference. Okay, already I told you this relational algebra it's purely mathematical concept. Okay, so under that what is mean by a selection itself, I just give the clear picture itself. Okay, so what is mean by just we go for some normalize or just example, we go for something in interaction with your table at the time, what are the constraints you will follow, that is base concept as the relational. So relational it's the some selection process we move on the horizontal wise. Okay, then projector is some vertical assumption, that is called we have to some table is student table itself, student roll number and student register number and student should name, age, etc, etc. These are all the following the sequence manner, that is called the selection process. When projection itself, that is called I think we have to follow some selection operation. You know that only for the select I want to the selection student name itself. Okay, so simple query it's the select, then select table name, follow the where statement its utilization, and you follow the name. Okay, that is called projection. And here it's the next one, Cartesian product. What is mean by a Cartesian product itself, I am already told you. So here is two different table, one is the R, another one is S. Okay, so R is the sequence of two constraint, one is the A and the B, and S is the another three constraint, that is called 1, 2, 3. I am already told this is one table and this is another table. Okay, we finding the two elements with the significant for the A into A and A into 2 and A into 3, and B also contraction from 1 and B also contraction 2 and B also contraction 3. So these table we finding the some new solution of R into S. Okay, so this is method followed by the Cartesian product. And even previously previous slide, you know the very well about the union, okay, R union of S, that is called R and S. This is total two different slides, two different tables as there. Then two tables are you just merge, okay, that is fully copied or fully displayed. Then intersection, it is totally different. Which tables are commonly present of your R and S, that is called interruption of your R intersection of S. Then segment is, that is called the set difference, okay. It's previously, for example, I have your S is one more attributes added is A. So now the precise of element is A, B and 1, 2 and 3, that's all. A it's not repeated because of this is concept of set difference, okay. So this is the basic picture, and move on the next one. I slightly difference of joining process also, okay. I already told you joining process is also presented. So I think T and U, this is two different of tables itself, and joining infinity, isn't it? So how many times are you repeated? Because of joining operation, so many things are there: natural joining, outer joining and inner joining, etc., etc. there. So that we have to follow some mathematically applications. We will elaborate in this next session. Then first one, we see the relational of selection, okay. So what do you mean by a selection or restriction? Selection, it's a sense, we just call it, you have to some table that is called employee table. I want the employee manager itself, how do you follow? So simply called as select the table of employee where statement you apply, it's neglected, isn't it? That is called your normalized. As it is same principle, there is normally difference your DBMS, but I already told you DBMS or RDBMS totally different. So that I am using for the selection operation is the predicted symbols, okay. So that the predicted, that is the symbol as, the predicted is the condition statement. Then R is the relational. Relation is nothing but a table, okay. That the meaning is, the works on a single relational R and define a relational that constrains only those tuples. Tuples means rows, okay. Then of R that is satisfy the specific condition is predicted. Already told that it is predicted as a condition. Now the selection is presented as at the statement is condition is followed, then which tables are you related. So some examples are given as list all the staff with the salary greater than as 10,000, okay. This